11 for grade 8 is all about probability. So 11.1 deals with tree diagrams and tables. 11.2 is outcomes of independent events, and 11.3 is probability using fractions. Then we'll have a major quiz, i.e. an exam, once that is all done. So today, 11.1, determining probabilities using tree diagrams and tables. That's what's up first. There it is. So working example number 1, determine probabilities from a tree diagram. So let's start with the definition. Independent events. That's two or more events that do not affect each other. So for example, spinning a spinner has no effect on what happens if you also roll a die. So those are independent of each other. Alright, so what is the probability of spinning A on the first spin using this spinner here? Write your answer as a fraction, a decimal, and a percent. So A, there's one section here that has an A. So that would be your favorable outcome. There's one favorable outcome possible on this spinner. How many possible outcomes? Well, there's 1, 2, there are 3 equal sections. So your denominator is the 3. So 1 divided by 3 gives you the probability of spinning an A. So 1 over 3, well, that is a fraction. That is the fraction form. To convert it to decimal, just take your calculator and do 1 divided by 3. And you'll end up with this 0.3333. It's a repeating decimal, so you can use bar notation. So 0.3 with a bar over it to simplify things. So to summarize, the probability of spinning A is 1 over 3. It's 0.3 with a bar over it. And then we also were asked to do it as a percent. Well, you take the decimal and multiply that by 100. So your percent in this case becomes 33.3 with a bar over it, percent. And that's all there is to it. However, we can also use a tree diagram to look at our sample space when we spin the spinner twice. So, sample space is all of the possible outcomes of the events, not just the favorable ones, but all possible outcomes of the event. So if you spin a spinner twice, you need to have 2 columns. One is for spin 1, one is for spin 2. In this case, we've got 3 possible outcomes, A, B, and B. So that's going to be what we indicate for our first spin. A, B, and B. So that's the first spin. The second spin also has the possibilities of A, B, and B, but you need to split this. We've got one possibility for spin 1, so spin 2 could be any of those. And then we just repeat ourselves, A, B, B, A, B, B. So now if you look, there's different paths you can take to get to your outcomes. Spin 1 can be an A, spin 2 could be any of these. So we've got AA is the top path, AB is the middle path, and AB is also the bottom path. Here we've got B first. Top one of these ones is an A. Middle one is a B. And then the third one is a B as well. So now we've got 6 possible outcomes established. The third spin could have also been a B, or the first spin could have also been the other B. And so spin 1 was A, or if it's B, then it could be BA, BB, and BB. If the spinner had 3 sections, A, B, and C, then the tree would look almost identical. This one would be a C. And then the third one, this would be a C, this would be a C, that would be a C. So it's a little bit different if you had 3 sections, but not much different. So in total, there are 9 possible outcomes when you spin the spinner twice. If you'd spin it a third time, then each of these 9 paths would have to be split into 3. So then you'd actually have 27 outcomes if you had 3 spins. And then after that, you would have, what is that, 91 outcomes or 81 outcomes if you'd had a 4th spin. But that is the structure of a tree diagram. Next question up is, what is the probability of spinning A, then spinning B? And you can write that as P for probability in brackets, then you put A, then B. So A is your first spin, then B is your second spin. So whatever you put in the brackets, that's what you're asking what the probability of that situation is. Write it as a fraction, decimal, and percent. So we've got our tree summarized here. Spinning an A first and then a B. Well, look at it. The first spin A, well, it's not going to be any of these bottom ones. It has to be one of these top ones. And then spinning a B. Well, it's not this one. You'd be looking at these two possible outcomes. So that happens twice, which means out of all the possible outcomes, there are two favorable outcomes if this is the question you're asking. So then you're going to have 2 out of a total of 9 possible outcome paths. So your fraction is 2 over 9. Again, as a decimal, 2 divided by 9, and we'll get you 0.22222. So it's a repeating decimal with a 2 on it. So using bar notation, it becomes 0.2 with a bar. So then let's summarize. Probability of spinning an A and then a B on the second spin is going to be 2 out of 9, or 0.2 bar. And as a percent, you just multiply the decimal by 100, so it becomes 22.2 with a bar over it, percent. So when you're asking a question like this and you've got a tree diagram, look at your outcome column and figure out how many of those outcomes match the question that you're being asked. That becomes your favorable outcome total, and the total number of possible outcomes is your bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it's just dealing with converting between fractions and decimals and percents once you've got that figured out. D, use the tree diagram to find the probability of getting the same letter on both spins. So either A both times or B both times. Right answer is a fraction, decimal, and percent. Well, let's go back to this. Both being the same. I'll just erase that. So AA was a possibility. Those are different. That BB is a possibility, so those both are favorable. And those are both favorable. So I've got 5 ticks here. So there are 5 favorable possibilities, or 5 favorable outcomes on that. The total number of outcomes hasn't changed. It's still 9, but the favorable has changed because the question changed. So 5 out of 9 is 0.5555, etc. So it's a repeating decimal. So 5 over 9 is our fraction. 0.5 with a bar is our decimal. And then our percent is 55.5 with a bar over percent. So the favorable outcomes really depends on what the question is you're being asked. You can use the same scenario and ask lots of different questions, and the only thing that changes is the favorable outcomes. All right, next up is a show you know. Please go ahead and get started on that.